This is 11.1 Fundamental Counting Principle. Now we use the fundamental counting principle to figure out the number of outcomes in a probability problem. So this is setting the foundation for those future probability problems that we have coming in the next chapter. Let's take a look at this tree diagram. In red, we have three selections: chicken, salad, turkey, grilled cheese. In the blue section, our side dishes, we have chips, French fries, or fruit cup. And then for drinks, we have soda or water. If you take a look at the bottom, right below this, it says there are 18 total combinations. So there's 18 different combinations that you can make by selecting one of each category. Let's look at how the fundamental counting principle works. It takes the number in each category. For instance, chicken, turkey, grilled cheese, I have 3 options to choose from. Side dishes, chips, French fries, fruit cup, I also have 3 options. For drinks, I have soda and water. All right. According to the fundamental counting principle, we take the number of options that we have in each category and we multiply them. So 3 times 3 times 2 is 18, which matches the total number of outcomes that was demonstrated here on the tree diagram. The formal definition of the fundamental counting principle is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. Basically the same thing that we did on that first page. Pick one from each category, but count how many options you have within that category and multiply those together with the other categories. All right, let's take a look at this problem that we have. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? This 2-course meal means that they're going to select 1 appetizer and 1 main course. So we have 6 appetizers, 14 courses. We'll take 6 times the 14, and that gives us a total of 84 ways to select a 2-course meal. It is that simple as long as you know which numbers to multiply. Now let's take a look at this next image. We have a gentleman here. Perhaps these are his available clothing items that are clean, if you want to say it that way. He needs to select a pair of pants, a shirt, and shoes. So we're going to take a look at what he has available. For the pants, he has 2 options, blue jeans or black slacks. So there's 2 options there. And then he has a shirt or shirts to select from. Yellow, beige, or blue. There's 3 options there. And then for the shoes, he has 2 options there. He has red or black, so 2 options. And again, these are the number of categories. He has pants, shirts, shoes, your categories. Within each category, 2 options for the pants, 3 for the shirts, 2 for the shoes. If we multiply these, we get 2 times 3 times 2, which will give us 12 options for an outfit. And we can double check that with this tree diagram. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. So there are 12 outfits that he could possibly make with these categories. Let's carefully read this problem. Next semester, you are planning to take 3 courses, Math, English, and Humanities. Based on time blocks and highly recommended professors, there are 8 sections of Math, 5 of English, and 4 of Humanities that you find suitable. Assuming no scheduling conflicts, how many different 3-course schedules are possible? All right, so the 3-course schedule means that 3 courses you're going to select 1 Math, 1 English, and 1 Humanities. So let's write this out. So for Math, we have 8 sections. For English, you have 5 sections. And for humanities, you have 4 sections. Again, according to the fundamental counting principle, if we want to know how many different course options you have or schedules, you're going to take each one of these and multiply them together. And that will give you a total of 160 possible schedules. And I'll write this formally for us. So there is no way you shouldn't be able to pick some kind of schedule out when you have 160 possible ways to choose from. All right, so let's read this next problem. A restaurant offers the following limited lunch menu. Main courses: turkey, spaghetti, meatloaf, shrimp, hamburger, vegetables, corn or green beans, beverages, coffee, tea, milk, soda, shakes, desserts, ice cream, brownies. If one item is selected from each of the 4 groups, in how many ways can a meal be ordered? So let's count how many main course options we have. And we have 1, 2, 3. Looks like we have 5 there. Vegetables, you have 2 options. Drinks, 5 options. Desserts, 2 options. In how many ways can a meal be ordered? That is the fundamental counting principle. So remember, we're going to take 5 times the 2 times the 5 times the 2. And this will give you the outcome of 100 ways to order the meal. Okay, it is that simple, folks. You just need to remember that you need to count how many in each category and make sure you multiply each of those numbers from that category. All right, so this problem is just a little bit different. So let's carefully read this. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices, with 1 correct answer per question. If you select one of these 4 choices for each question and leaving nothing blank, in how many ways can you answer the questions? So I'm a very visual person, so I like to draw out the lines representing each test question. So we'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, for instance, this is just representing the first question. Each one of my lines represents a question. Now, when I take a look at just question number 1, I notice that it says on here, each question has 4 answer choices. All right, so question number 1 has 4 possible choices to choose from. Kind of like on that last restaurant, I had 5 choices to choose a main course. For the first question, I have 4 choices to choose and answer. Same situation, just a different scenario. So for each of these questions, if you think about it, I have 4 choices. Go all the way out to question number 10. And then again, we're going to multiply each of these. And of course, there's a shorter way to rewrite this. We know we have 10 questions, and each question has 4 options. So here's my 4 options raised to the 10th power. And if you place this in your calculator, you should come out with 1,048,576 ways to answer those test questions. Isn't that amazing? That is an obscenely large amount of options. All right, so once again, write down a little mark for each one of your questions and ask yourself, how many ways can I answer each question? All right, and that is 4 to the 10th power. All right, this last problem is similar to the previous problem, but it has some unique differences in it. So let's read carefully. Telephone numbers in the United States begin with 3-digit area codes. 3-digit area codes. So I'm going to put 1, 2, 3. That's my area code, followed by a 7-digit local telephone number. So 1, 2, 3, 6, and 7 digits. All right, so an area code and local telephone numbers cannot begin with 0 or 1. So they're giving us a limitation on here. Area codes and local telephone numbers cannot begin with 0, 1. And the question is, how many different telephone numbers are possible? So the first thing we want to do is go figure out what kind of numbers we can use for these values. So if you think about it, we can use the numbers 1, 2, 3, 4, 5, 6, 7, 8, and all right. And then let's just count how many different choices we have on here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 numbers to choose from. All right, total of 10. Remember up here on the top, cannot begin with a 0 or 1. So that says they cannot. So the area code here and the local telephone number, the very first digits here, cannot use 0 or 1. So if we started out with a total of 10 options and we cannot use 0 or 1, that knocks out 2 of our options. So that means we only have 8 options to choose from for those first 2 numbers. And then as we continue on with the rest of the digits, we have 10 options, all 10 numbers we can use. And everywhere else will be 10 digits that we can choose from. So what that's giving us is it looks like 8 to the second power times, and 1, 2, 3, 4, 5, 6, 7, 8. We have 10 to the 8th power. All right, and if you put this in your calculator, we should get another large number. Make sure I count all my zeros here. All right, and that looks good. 6,400,000,000. That is different telephone numbers. All right, so remember, take your time, read through these carefully, highlight what's important, and also focus on what are you trying to find. I believe we were okay in finishing this one out. All right, and this is the end of 11.1.